of this webinar is to explain you why to use AEC Collection for infrastructure projects. My name is Tomáš Lenvorsky. I am a senior technical specialist for AEC based in Prague and responsible for what we call CHSM Poland, basically for Eastern Europe. So with any delay, let's start the presentation because I believe I have a lot of things to tell you. So let's jump in and let's explain why to use AEC Collection. So why to change? This chapter I call why to change because I believe that each of you has some tool already using, so it can be AutoCAD, it can be Civil 3D, or it can be mixture, and now you are most probably asking why I should start to use AEC Collection where there is a lot of products and I'm supposed to learn all of them, not why. So the goal of this presentation is really to explain you what are the benefits for different personas in designing process, and so let's have a look at why. So I will start with a nice video which has been done, by the way, by one of our customer in Norway. So basically it's Sweco for their Janna Benemaker, which is in fact a railway company, and this is the project where they were making study for preliminary design or study for railway. It is a huge project, over 150 kilometers of new rail, and obviously they wanted to explore what are the best possibilities. And here, even if you don't have such big projects, so let's talk about smaller project, but why I'm showing it to you is that the goal of today's design is to show not only design, but design with non-graphical information, basically having in one place everything stored and being able to communicate this with other stakeholders. And the stakeholders can be really other designers, can be investor, or even can be public, you know, when you will need to go for public hearings and you will have to communicate your design, so you should show it. And obviously if you go to public hearing, you don't have to show all the information, but you should show how the project will look like, and obviously depending on the level of detail you will make a decision how many details or what is the stage of the project you will show to the people. And always what is important is communication on the project. So this is how the project can look like, and why it's happening, why people are changing. People are changing because of new BIM mandates and standards. And now you can say, okay, we don't have any BIM mandates in my country, so why should I change? So, and in fact, it's not only about BIM mandates. Even though you can expect that BIM mandates sooner or later will come to your country and you should be prepared. However, even nowadays, you don't have only mandates, but you have also projects. So here are the projects from vicinity of Czech Republic. Here is Fistal Bridge in Germany, for example, and in Germany is planning to have full BIM standards in 2020. Here is Rail Baltica, basically connecting all Baltic countries, Lithuania, Latvia and Estonia, and going to Poland. And even though these countries, they don't have BIM mandates, they decided to make this huge project in BIM. And here is another example from Slovenia. Even though in Slovenia they didn't have at that time any BIM mandates, the investor asked to make a new tube of Karavanke tunnel in BIM, so that they had all information, not only for visualization but really 3D model for scheduling and for cost estimation in 3D, and not only tube but also surrounding infrastructure. And the latest example is from Croatia, Pelešački most, basically bridge between inland and Pelešac peninsula. so which will be designed in LOD, level of detail 400, and this country do not have any mandates. So these are the reasons why you should also think to move to BIM, to more advanced techniques. And even if you say, okay, BIM is not important for me, so why I should care about AEC collection? Because it's important to be connected, because in fact you should be connected with your peers, and it's not important only to have design on your computer, but it's important to share your design with other stakeholders across the entire life cycle project, regardless if you are in planning phase, conceptual stage, detail stage, or even in build stage when you are sharing your design with construction site. And another reason is new technologies. New technologies are coming, or they are already there. So on the right bottom corner you have GPS navigated machines. Okay, this is already an everyday job to prepare data for GPS navigated machine. But you have point clouds. Basically now the servers, they are creating millions and millions or billions of points. So how to use it? Prefabrication is coming. So basically there is a lot of prefabrication coming on the construction side. So there is a mixture of basically AEC construction and manufacturing, and also then you have virtual reality, augmented reality, and all that kind of stuff which is necessary nowadays to present the project and to communicate the project intent. So these are the trends, and this is why you should consider to move yourself to the, let's say, next level, and how the next level can look like. And as I promised at the beginning, I will be talking about different personas in the designing process. So let's have a look to the land surveyor, because there is where everything begins. So how the land surveyor can use our portfolio. So the task of land surveyor seems to be easy, but in fact it is not very easy. He has to collect all information coming from GIS, reality capture, Internet of Things, IoT, or other BIM. So, and he should put everything together to create one information model which will be used in design process. And our tools are helping the land surveyor to use all this information. And obviously due to time constraints, I will not explain everything, but I will touch some of this. So first is GIS. There is no design in infrastructure without GIS. And our idea is to really connect GIS to BIM. And not only this, we want also to bring BIM back to GIS. And we are working closely with Esri, and we are working on processes how to do that. And here is the first, let's say, a result of our collaboration, which is connected to ArcGIS. So basically, what we are capable of doing is to bring data from ArcGIS to InfraWorks. So have a look here what we have. We have some map created in GIS. And then let's go to InfraWorks, which is Autodesk product, and you have possibility to connect directly to ArcGIS, and now you can configure your data sources, which means you are selecting what you want to bring and how you want to bring it. That InfraWorks will understand what is it, and he can interpret it. And not only interpret it, but then you can analyze it. So for example, land use, how the land is used, and then you will use color to bring it. So right now it's colored based on usage, if it's farmland, industrial, etc. So, and then you have all information, including, for example, pictures, because you can add pictures. You can basically create your what we call schema and bring all information which are available in GIS to InfraWorks. It's really up to you. And now let's imagine that ArcGIS is live. So basically, a server is working outside and he's adding new information. So it can be new survey or adding new information to the existing assets. And then just in InfraWorks is enough to say basically update, and system will refresh everything in InfraWorks, and you have all information back in InfraWorks. So it's first example how GIS can help designers at the very beginning and having all information for design. Another is reality capture. So reality capture can be basically mobile radars, going on the street and making point clouds, or it can be here example of drone which will make point clouds plus pictures, and then you can use it in InfraWorks, and we can basically prepare the data. So let's imagine that we have existing context which we brought from different sources, and then for this small particular place, because there will be maybe some rehabilitation of the road, we have point clouds. So what we have is tools to help surveyors to automatically detect vertical features like trees, lampposts, lights, and stuff like this. And then we are not only capable to distinguish what is the terrain and what is the vertical object, but we are helping surveyor to add the features according what he wish and to display it. And then here we have tools to semi-automatically create horizontal feature lines, what we say, so by lines, where is the center line, where is the edge of the road. Land Saver has a full capability of modifying it, so basically he can go through cross sections and modify it if something got wrong, or if there is some noise, there was some noise, and then we can bring it to detail phase to make a really detailed surface for design of the road in Civil 3D. So another reason why to consider InfraWorks for land surveyor to basically pre-process the data for design. And here is just to show you why and to which products land surveyor can use. So it can start with Recap. Recap is tool which is helping to process laser scan. So you can imagine that you have different providers of laser scan which in different formats, and the big advantage of Recap is that he can process the laser scan, so we can bring different formats in. We can in Recap to do some cleaning, so basically to get some noise out of it, and then very important is that the system will create one format which can be used within any our products. So it can be InfraWorks, Civil 3D, Revit, so basically any products which you have, so for example 3ds Max, and you can use it. Then I was talking about InfraWorks. So in InfraWorks we can process or post-process point cloud data to create really surface to distinguish what are the vertical objects, bring in GIS data, and create the terrain model. I didn't talk about conventional survey because I believe it's obvious that we can bring points, we can bring survey data, what surveyor measured outside. So whatever you want, you can bring it, and in Civil 3D you can process this, and you can later on bring data from InfraWorks, which means point cloud and GIS. You can use data from Civil 3D, and you can in Civil 3D create terrain. And also it's not mentioned here, but the data which you created here in GIS you can bring over also to Civil 3D. So later on for detailed design you have all available information. And maybe what I should mention is that Civil 3D is based on Maps 3D, so basically all functionality of Maps 3D is inside of Civil 3D, which means that Maps 3D has also functionality to bring GIS data in, not to using InfraWorks, for example, but directly using what we call FDO providers. And then we have functionality to analyze it, to stylize it. So basically you can play with this really to get displayed of the GIS data the best way. So As I mentioned, the goal of this presentation is to explain you what are the benefits of AEC Collection, for example here for land surveyor. So you can see that he can use all this few of our products from AEC Collection. So let's move on. Road designer. Road designer is another persona in the team, and he obviously will use survey created by land surveyor. And then let's go and let's have a look at how the designer can create conceptual design. So here we have a context model created in InfraWorks, and then we had some PDF which we brought in and display from planning phase, you know, just to make a conceptual phase. So you can see that I'm using in fact alignment functionality to create alignment profile to create road, which is already not just some picture created in some CAD, but it's really three-dimensional model with other assets, not only road, but you have green strip in the between. We can use, obviously, because we have profile, we have road, we have super elevation. So you have here also cut and fill, basically earthwork. So and we can have a look what was intended. So basically here, for example, the intention was here to make a roundabout. Just on one click I say okay, change a normal junction to roundabout. So then we can even optimize vertical profile. So basically based on some criteria, system will optimize the profile for cut and fill balance. You can see all information based on the cross section. So or you can do it with a manual, it's up to you. As I mentioned, because it's based on some rules, system knows what are the what is the design speed, so we can check what is the super elevation. We can modify super elevation, and so we can calculate also later on volumes, which is here. So because now I have cut and fill, so I can create reports. I can see how it's going on, and obviously in this phase we can do other analysis like visibility, which is in 3D, or here's example of traffic simulation, how this road will affect the surrounding areas. So on the cloud system will calculate based on of course of our information how many cars will be traveling from one point to another point. So we can visualize what is the impact of this new design. So if there will be cars queuing somewhere, what will happen there. So you saw the conceptual stage of road designer made in InfraWorks. So let's make further. So let's go to the detail design. So here is another example from different project which we did in Poland based on in here Polish country kit. However, there is obviously also Romanian country kit, so basically all the standards will be automatically available. And now it's just showing you how easy it is to bring the data from InfraWorks, because in InfraWorks we already made the design, we have existing terrain, we have GIS data, and then just saying which part of model I want to bring in, because in InfraWorks I can have a huge model, but for example for detail design I need to create just some section of 10 kilometers or something like this, because this is my part. So I can bring the data in and just waiting a little bit, and system is bringing all available data from within InfraWorks to Civil 3D. So now I will just switch off my map because I don't need it anymore, and all information which were available in InfraWorks are available also here. So here is example, for example, of the bridge where we created bridge in InfraWorks. So the data are brought in. So we have alignment, we have profile, we have corridor, and all information are here. And obviously we can use standard Civil 3D functionality to modify it. So now I decided to change my road, so I will create different assembly. So to show also that there will be maybe some tunnel, not only a road. So Civil 3D, we have what we call subassembly composer, where you can design your own cross-section, basically standard cross-sections based on different criteria, and here was the bridge. So now I will bring this information in and I will create a new corridor. However, as I mentioned, this corridor can be brought from Infraworks as well. It's up to you, it's your decision what you want to achieve. Here in this project I decided I will do it separately. So now I have road, including tunnel and bridge, and I can create here, for example, cross-section. So now I'm saying to system where my cross-section views will be created, in which frequency, along the alignment, so tangent, curves, spirals, and I have all this information. And because Civil 3D is based on dynamic model, obviously if any change is happening, it will be populated to all information, to all depending drawings, including section views, including profile, etc. So, and now you see that I have this tunnel, I have road with all information, and cut fill, so basically different scenarios. And have a look what we can do. Now I'm bringing the data from GIS again, from Infraworks. I'm bringing buildings because I made a road and then I realized, oops, where are my buildings? So I'm bringing it in. I just forgot it. It's obviously possible. And now I realize that my design is not the best one, because you can see that my fill is or my profile is too high, so I would have to destroy several buildings, which is not very nice. So I decided to replace some retaining wall, so basically to change, to modify it, and just as I said, it's based on parametric on dynamic model. And now I will just say, okay, I want to use retaining wall assembly, set up the targets. You can see that I can define, for example, geological layers to define where the basement, let's say foundation of the retaining wall. So all this information can be defined. It's really up to me if I have this information or not. And in a matter of few seconds, I change my design. So from this, let's say, fill which would destroy buildings, I put here retaining wall, and I can continue my design. Obviously, now I can calculate the volumes based on cross-section for different layers, etc., etc. So because Civil 3D is not only about detailed design, but it's also about analysis. And if you are talking about analysis, another way of analyzing a model is, for example, sweep path. Not only volumetric calculation, but if I do some, it's for example in town, so here is some logistics center, and now I want to investigate if my design is really capable of hosting some big tracks which have to come in and obviously have to park if there is enough space, and so on and so forth. So I'm using capability of now what we call vehicle tracking, another tool which is available in AEC Collection, and we can analyze it. And you can see that we have a lot of other functionality which we can use to modify our basically driver behavior, so we can allow him to go a little bit on the left side, and then we can visualize it. So basically we can see if this track will really get in, and he will be capable of parking even, so we can define the moving backwards, so we define how to come to this position and how to bring it in. So it can be visualized and it can be presented to other audience. So what I showed you is again several products which can be used in different stages of road design by road designer. And again, as a surveyor started in Infraworks, same here, he can use road designer in Infraworks again as well for conceptual design. Then detailed design, where we can utilize the data which has been already created in Infraworks, and also don't forget the data which has been created by a land surveyor. So then in after making design, we can make documentation and volumetric calculation, for example, based on what we design, earthwork, different layers of asphalt and pavement and so on and so forth. And then we can do also project analysis, and I showed you one example using vehicle tracking, very simple tool to analyze really tracking our path of the vehicles. So, and again, you see that the road designer, for different stages of his job, he can use different products, and obviously then we could create different scenarios. If maybe he needs to create some visualization, that we have connection to 3ds Max using what we call civil view directly to connect it and to visualize what he did, etc., etc. So again, wide variety of things how a road designer can work in different stages in different products, and obviously these products are designed the best way for these stages, for conceptual design, for detailed design, etc. Next one is another persona which I selected. Obviously, if you have road, parking place, whatever, obviously there is always some rain. And what we don't want to see is rain, the water on the surface of the road or parking place. So this is why drainage designer is coming into the place, and he is making his drainage design. So have a look which tools he can use and how he can utilize again AEC Collection. So here is example of a parking lot that because I just want to show you that we can design not only roads, rails, but also parking lots, basically some aerial spaces, and he is laying out his drainage. So he is making decision where the drainage will be. This is really conceptual stage, but again, he can visualize it, there is manholes and everything, but then he can bring it to Civil 3D and make detailed design. So in InfraWorks he already designed some sizes, but now he can modify the sizes, so he can modify the diameter of the pipe, slope of the pipe, and so on and so forth, so up to him. And then he can create a longitudinal profile, but more importantly he can make analysis, because this is what is very important. And just to explain how it works, in a Civil 3D we can define what we call contribution area. So basically system can find automatically for each manhole contribution area from which area the water will go to which manhole or which inlet. And then based on this we can make analysis in what we call storm and sanitary analysis tool, which on one click you will just say from Civil 3D, okay, send the data to storm and sanitary analysis, and now you can see after a quick analysis that some pipe will be surcharged. So basically it's too small to accommodate the water from area. So then we can obviously change the diameter, we can change the stuff. But I would like to see it in profile view. So let's say, okay, now I'm interested in this path. So I selected the start point, end point, and I have here my profile view, including, you can see this blue color is the level of the water, and you can see that in these two manholes there is surcharge because it's too small to accommodate. So it will, if I specify, for example, 20 years water, because again it's up to me, intensity, how much, and so on. And this is definable, and system will tell me, okay, this is too much. And then here in storm and sanitary analysis, what I can do, I can modify the drainage, I mean my pipes, my manholes, and then I can bring it over back to Civil 3D. So it's really a closed loop that all data will come back to Civil 3D where I have entire detail design. So, and over is the documentation. And this is the workflow, and you can see that drainage design, for example, can use 3 different products from our portfolio. InfraWorks for conceptual design, just to really sketch where the drainage will be. Civil 3D is really a tool for detailed design, so designing or defining diameters, manhole types. Obviously you can change types of the manholes, shapes, and so on and so forth. For analysis, we have storm sanitary analysis, and again, it's going back and forth from Civil 3D to storm sanitary analysis and back to Civil 3D, so all data will be available back, and even after analysis, the data will be updated, and we can create documentation. Basically, what is most important is profile view, with drainage, with depth, with all information, diameters, slopes, and so on and so forth. So again, you can see that the drainage designer can utilize several products from our portfolio for his job to make really a nice design, and the design which will help to drain the road or parking place, whatever it is. And then let's go to have a look to the bridge designer. Bridge designer is another persona, because if we are talking about infrastructure design, obviously there are always some structures. So it can be bridge, it can be tunnel, but it can be also other stuff on the road. But let's imagine we have bridge, and let's how we can deal with this. And again, bridge designer, he has a model of existing context. He knows what he wants to connect with what, and he can start to make a design. And obviously now it can be, this alignment can be done by road designer. It's just showing you a workflow. But then road designer can come in and he will say, okay, from here to here I expect the bridge. And the system will create bridge for him based on rules, based on spam. System will at abutments, piers. He can design also how the top of the road will look like, if there will be some railing, etc. So really detailed design already in this stage. Obviously not all piers will be rectangular, perpendicular to a road. We can rotate it, we can play with this. You can have a lot of parameters. And we are providing with different elements for pier, for abutments, etc. But there is full basically modeling capabilities in Inventor, which user can define. Almost it will be some administrator. He will define different types of piers. You can bring it directly to InfraWorks, and then you can just apply it. So basically there is any possibility is available to create your own library or the library which we are delivering. Here's another example that we can make structural analysis of the bridge. Basically what happened is we send the data to cloud, system made the cloud in cloud analysis, and structural design, structural analysis has been brought back. And then we can check it, and then on one click we can bring it to Revit, where obviously in Revit we can do documentation, and we'll see it next in the next stage. So this is quickly workflow which can be done. So basically we have alignment coming most probably from road designer. Bridge designer can design the bridge from where to where, from which station to which station the bridge will be, define the piers, define the number of the piers, etc. And obviously how bridge will look like, and then we can analyze it in cloud and bring it to Revit. And as I mentioned, Revit is dedicated for drawing deliverables. So what we can do is that we can send on one click to Revit, and everything which has been designed in InfraWorks by bridge designer can be sent and then detailed. And it is not only about documentation, but for example rebar. So basically we can add reinforcement, we can make sections, we can annotate it. So basically again Revit is the tool for detailing and documentation creation. So sections, views, isometrics, and so on and so forth, that you can create the deliverables documentation which you can send to your investor. And let's have a look in detail to structural analysis, because I showed that we can do structural analysis. So as I mentioned, we can do it in cloud. Obviously there are some settings so which you can define. You can specify who you are, what you are doing, and you will start the analysis. What's happening is system is sending the data to cloud. You have to wait for some period of time. Obviously, it's not as fast as here on this presentation, but after several minutes, you will receive the results, and you can get a full report. So basically, then you can have a look, and you can go. And for this bridge, I believe it was about 130 pages of analysis, how it has been calculated, what has been calculated, against which standards, if it's UK standards, Euro standards, AJUTA standards. So basically, you can define different benchmark criteria. So here US design standard, Eurocode. And then, as I mentioned, you will receive back PDF with a lot of information. So here is 180 pages for each pier, each beam, so information about shears, how it has been calculated, what has been calculated. So really very detailed information what's happening. But not only that. Maybe you are not happy with cloud, so you can bring it to desktop application, which is called AutoCAD, Autodesk Structural Bridge Design, where you can modify this even. So basically, let's imagine that you expect some military convoy which will be passing through the bridge. So you want to add another load, not standard load, but some different load. And you can see here you have a lot of functionality, how to modify it, how to reanalyze it, how to get information back in, and again, obviously, to get reports, what are the loads, and so on and so forth. So all these information are available, and you can use them. So again, let's have a look what we can use in bridge workflow. So parametrical parts for InfraWorks are made in Inventor, but then you have all, and maybe what I should say is that Inventor is not part of AEC Collection. However, this is something which is used, let's say for short period of time when you will create these parameters, this parametrical library, and then you will just utilize it. So basically, it's just a question of renting maybe Inventor for 3 months to create a library, and then you are done, and you can reuse all data again and again and again. In InfraWorks, where you will make the bridge design. I mentioned that you can make structural analysis either in cloud or in a structural bridge design on your desktop. And then all documentation, views, sections, annotation, and that kind of stuff will be done in Revit. So again, full work, and of course reinforcement. I forgot about reinforcement. So full workflow, how to cover really detailed bridge design in each and every stage, and with details needed. And have a look to another persona, and this can be chief engineer. Basically somebody who should have idea about entire process. However, he doesn't know how Revit works, how Civil 3D works. So basically, this persona needs to view the data, and he needs to coordinate everything and to collaborate. So, and here our proposal is to use what we call BIM 360, where we can basically upload any data, and not we, but customers obviously, and it's automatically versioned, and then he can view it, and you can see that he can view it in just internet browser with all information which has been designed. So basically here is an example of this retaining wall with all information which has been added with retaining wall, what is the concrete type. So with all information available with no need to understand these original products, and being able to aggregate all data. And now we moved, he can download the data, and he can make the analysis. So maybe analysis can be quantity. He can quickly check what is the volume, and now he has the data. He doesn't know how to create cross sections, or he doesn't want to know it, better said. So, but now having information about the model, he knows that he wants to get information from basically some layer 1, yeah, and he will find all information within the model, and he will quantify it. So basically he will just send this information to a quantification workbook, and he has all information about the volumes. So you see that he doesn't have to rely only on designer, but he can do his stuff by his own. And another important thing is that all the data are connected back to the original one. So if the original model is changed, then this chief engineer can just upload a new version, and he can just update his Navisworks model. And here is another example what he can do, maybe to simulate the work basically based on the timeline, how for example, this small project will behave in time. So basically now we are talking about 4D, not having only X, Y, Z, but also time, and we can simulate the construction sequences. And in any stage, he can stop it, he can view what's going on, what are the information, what are the properties of, for example, pier, etc. So he can view it, how it will work. Yeah, so he can select it, he can get all information necessary, or better said, which has been added to the model, etc. So what is important, chief engineer has tool where he can collaborate on cloud, but then he has very easy to use tool where he can interrogate the design from his perspective, from his point of view. And obviously this tool can be used not only by chief designer, but for example people on construction site can use it as well. But now I'm looking to the chief designer, what are his tasks. Another example is that because obviously safety is very important, so what will happen, for example, if there is construction company and they will bring some crane and the crane will move along the bridge, so what will happen if there will be some clash? Because what is another advantage of this tool, which is called Navisworks, is we can make clash detection. And we can make clash detection not only between two, let's say, fixed elements, but also between element and some movable object, and here it is a crane. So now I will say, okay, show me if there is some clash, and I will even say, oh, it's not hard clash, even if I am 60 centimeters close to the electrical post, just tell me that I am in trouble, and he's telling to me. So basically, if the arm will be up, so system recognize that there will be clash with this electricity, and then obviously we are in trouble. Safety is not very good, so we have to do something with this. So just example how it can be used, so we can rank report, we can send it to somebody, or again we can use BIM 360 cloud collaboration tools for sending this information out. So chief engineer workflow, so he can use BIM 360 to exchange the data. In Navisworks he can aggregate all data, he can make analysis, and also I didn't show, obviously he can view it. So if he doesn't know Civil 3D, he can use just AutoCAD, and then in AutoCAD he can open all the drawings, he can view it. He cannot design because obviously this is part of Raw Designer, but he can view it, he can view cross-sections and everything, and he can, for example, compare his volumetric calculation with the volumetric calculation which has been done by a designer, and so on and so forth. And then he can use also BIM 360 for communication. Basically he can make some redlining on the model or on the drawings in BIM 360, and he can communicate this with other people which are connected and which should reply to him, you know. And BIM 360 has a wide variety of tools for markups, for issues. So I don't want to go into the details, but there is really bunch of functionality which enables very easy communication, including email notification when somebody is having some or he's assigned to some issue and he should reply it by some date, and everything is stored, so it's viewable by administrator, so who responded, who not. So basically you can get a full view what's going on the project. So with that, I plan to finish in about 45 minutes because I believe that I gave you a lot of information, and obviously if you have any questions, please you can contact me on my email address, or obviously you can find more information on the internet pages of Autodesk. So with that, thank you for your attention, and I hope it made sense to you, and you appreciate that Autodesk is working on not only one tool but on the bunch of tools which can really satisfy the different needs of different personas on the project, and that we are really thinking about different stages of the project which you can really use and to really create not only nice models but models which are having detailed information, not only 3D but also additional information like non-graphical information, and really this model can be used by different personas. So with that, thank you again for your attention, and I wish you a nice day. Bye bye.